Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat, so at least we'll be ready to go. The agenda behind today's video is very precise and clear. We were taking few number of questions related to the concept of the probability which have come in GATE Engineering Mathematics year of 2021. Anyways, the agenda behind today's video is also very same. I would be taking approximately 5 number of questions, again from the concept of probability, which have come in year of 2021. So just wanted to know, what about the quality of video as well as audio? If it is clear, just write clear over the live chat. So agenda must be very clear to all of us. And the person who have been new over this series, my dear friends, we have been started a new series over the engineering mathematics, and it has been the 8th lecture on that series. What I am going to do over here, we are going to take all questions from the engineering mathematics which have come in year of 2021 from either of the branch, from civil, chemical, electrical, electronics, instrumentation, mechanical and PI, and we are dealing the each and individual problem in terms of their topics. So the topic which is running in current, it's nothing but the probability. Already the 2 video has been taken over the probability, and this has been the 3rd video over the probability. See, the next thing comes in my answer. What's the agenda behind this series, my dear friends? With the help of the questions which have come in GATE 2021, we are learning the concept which would be utterly useful for the GATE year of 2022. Anyways, without getting delayed, now it's best time to straight away jump into the problem. Just a minute. So here goes the problem. Yes, here comes the first question, and as I have been told earlier, all of the questions which are supposed to take in this series, definitely they have been the question which have appeared in recent year, which is nothing but the year of 2021. Just a minute. So this is what your first question is. For the better understanding what I would be doing over here, let me bring this problem into the working board. Tell me what would be the best most answer for this given problem. So the question is in front of you, and you had to give its best most answer. And probably the student who have a little bit idea about the discrete random variable definitely would be able to smash this problem out within a fraction amount of time. Tell me what would be the best most answer. Let me read the problem carefully, and then we'll go ahead with this problem. See what the problem states. The mean and the variance respectively of a binomial distribution of n independent trials with the probability of success as p are. The options were given as root over of np which is getting multiplied with the 1 minus of 2p, then goes np into np, then goes np comma np within the bracket 1 minus p, and here goes root over of np comma root over of np within the bracket 1 minus p. Tell me what would be the best most answer for this given problem, my dear friends. So the student who are well acquainted with this sort of problem, straight away they would be writing the answer, and that is nothing but, at very beginning they were talking about the mean of the discrete random variable, which can also be written as expected value of the random variable, and random variable has been taken as, has it been taken somewhere? Yeah, x is number of success, and that has been simply n into p. And similarly, if you'll be talking about the variance of the random variable, which is sigma square of x, which can also be written as variance within the bracket x, has been written as np into q. What is the q over here? The q is nothing but the failure probability in each and individual trial. So obviously, the failure probability can be connected with the success probability at any moment of time. So the sigma square comes to be np within the bracket 1 minus p. So from here, we get the sigma of x, which stands for the standard deviation of the random variable x. So obviously the square root would come towards right hand side. The result what we face is simply going to be np 1 minus p. So the 2 important outcome which we have brought out, the first is expected value, which is nothing but the mean of the random variable, and the second is nothing but the standard deviation of the random variable, and they have come to be n into p, and the next is going to be root over of np within the bracket 1 minus of p. Tell me what would be the best most answer. What would be the best most answer? There was certain mistake over the options probably. The best most answer is gonna be NP and then root over of NP within the bracket 1 minus P. So only change you can have, and what it is, I think you can do over here. It would be just root over of NP. It would be just over the root over NP. So till this point, each and everything must be clear to all of us. Anyways, let me go into the detailed analysis of this problem. If we talk about the expected value of the random variable x, which can also be written as x bar, how it's been defined. My dear friends, if you have been talking about the ungrouped data, in case of ungrouped data, the average of the collected data has been written as what? Has been written as x1, x2, x3 till xn divided by of n. In case of group data, it has been xj f of xj. Within the denominator side, you used to have summation of f of xj. My dear friends, so far you were calculating the mean of the collected grouped data, but here rather having the frequency distribution, you have probability distribution. That means for the each random variable you have got its probability mass function. So end of the day, what is going to happen over here? May I know what's going to happen over here? So instead the frequency distribution, now you have been dealing with the probability distribution. What happens at next? So obviously this x of I would become capital of X, which is nothing but the random variable, and here rather calculating its frequency, you would be talking about its probability of occurrence. Yes, and at denominator side you will be taking all possible sum of p of x, and once you will take all possible value of sum of x, definitely this worth becomes 1. So if you really want to calculate the expected value of the random variable x, so simply it becomes x p of x, where the x goes from 0 and will go till the all possible values. Till this point, each and everything must be clear to all of us. See, here it has been clearly given the type of distribution which we have been following within this problem. It's a type of binomial distribution, and in case of binomial distribution, its probability mass function is clearly known to me. What used to be its probability mass function? So x is equals to 0 to infinity, it would remain as it is. The probability mass function used to be n of cx p to the power of x, even you can write q to the power of n minus x, and the x starts from 0 and goes till, tell me what would be its maximum value? The maximum value would be n. Anyways, for the better understanding, let me bifurcate. What are they? The x is number of success. Similarly, p is the success probability in individual trial, and it would be uniform in all of the trial. The q is nothing but the failure probability in each and individual trial. N is nothing but the total number of trial. Yes, and if you wanted to calculate the expected value of x, which is nothing but the number of success, so obviously you had to follow this form. And may I know the maximum number of success, what it would be? The minimally you can have only 0 number of success, and maximum you can have n number of success. So mathematically, once you'll expand them together, now end of the day, the result what we get, it's simply going to be np, which has been already written. Yes, which has been n of p. And even probably 2 or 3 days back, when I was discussing about the expected value of the binomial distribution, even with the help of few of the numerical example, I could figure it out. Yes, the answer do come as n of p. What I say, whenever you learn the mathematics, try to dive within the mathematics. Just do not by heart the mathematics. And I know many of the students are doing the same thing, and end of the day, they would have only one complaint. Sir, we do not exactly understand what actually mean of random variable, random process, probability distribution, and probability density. That is why you used to have that doubt. So I would request, already I have lit over this complete concept with the numerical problem, so you would have a fair idea. Agreed? So in short, I can say on average this many number of success would be achieved, and that is nothing but the n into p. See, if the n goes up, If n goes up, what does that mean of it? That means the number of trials keep increasing, and as the number of trials keep increasing, on average the number of success would increase. That is the first thing. And similarly, if the success probability in the each and individual trial is increasing, then also the expected value or the mean value of x would increase. It's in front of you. It's in front of you. And similarly, if you'll be discussing about the variance, how the variance is being calculated, my dear friends? The variance is being calculated as expected value of x square minus of expected value of the random variable x to the power of or raised to 2. The same fundamental you can use over here. Expected of x is already been calculated anyways, you have to take its square, and the expected value of x square can simply be taken as x square of p of x, yes, where the x could be 0, number of success is simply 0, would go till n, and here comes x of p of x, where the x goes from 0 to n, and it is being raised to 2. It has been raised to 2, and the result what we get out of this is simply gonna be n p into q. Q is being 1 minus of p. Q is being 1 minus p. Yes. Anyways, it has been the variance of the random variable x, and hence if we wanted to calculate its standard deviation, definitely it would remain sigma of x. The root over would come towards right hand side, and it would become root over of np within the bracket 1 minus p. So the best most answer what we get is simply gonna be D. With the help of numerical responses also, we have figured it out that the best most answer which will be suiting to this problem is simply gonna be option 1. Now it's right time to hop into the next question. My dear friends, this problem has already also been the problem of discrete random variable. So let me copy this problem and bring it to the working board. So here goes the problem. The problem have come in production engineering recent year, that has been the GATE 2021. So let me move this problem into the working board. Anyways, just a minute. So it has been the problem from production engineering. Let me copy this problem completely. So by watching this problem, I would expect within 2 minutes probably, you guys would be able to tell me the exact most answer for this given problem. What the problem states, my dear friends, the probability mass function p of x. Anyways, there used to be the two probability functions. First is probability density function. When we used to have the concept of the probability density function, when we used to have the continuous random variable, and there we talk about the densities of the population of the probability values. And in case of discrete random variable, simply we talk about the probability of the each and individual values of random variable. That's the basic difference. There's a basic difference between PDF as well as PMF. PMF is a straight probability, where the PDF is the probabilities density. Anyways, it is not the right time to discuss about the differences between the PDFs as well as PMF. Once you'll read this problem thoroughly, you'll get to know the probability mass function of p of x of a discrete random variable capital X is being given as p of x is equals to of 1 divided by 2 to the power of x, where x could take its possible values, which starts from 1, 2, 3, 4. Obviously, the capital X has been a natural number. The expected value of x is, answer has to be given in form of integer. What does that mean by the integer? It could be 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Yes, it has to be rounded off. But once you'll solve this problem, you yourself would be getting the answer into the form of integer value only. So probably you will not have any problem as such. Tell me what would be the problem, what would be the best most solution for this problem. My dear friends, what I would be doing, for the better understanding, let me draw the probability distribution. See how the probability distribution table would look like. At very beginning, I would be discussing about, or I would be dedicating the first column over the random variable, which has been taken as x, and in second column it has been clearly dedicated towards the probability mass function of the given random variable x, or simply I can say the probability for the occurrence of x maybe as 1, maybe as 2, maybe as 3, maybe as 4. Anyways, at very beginning, let me start with the x is equals to 1. What would be the probability that the x would gain the value as 1? That would be asked from its probability mass function, which has been clearly given as a 1 upon 2 to the power of x. That means x would be simplified as 1. Similarly, now the x can take its next value as 2, and here it becomes 1 divided by of 2 to the power of x, and the x has been 2, so it becomes 1 divided by of 2 to the power of 2. Once we are done with this, we can take the third possible value, and it would lead its probability mass as 1 divided by 2 to the power of 3, and you can have infinite many possible values of x, and obviously according to that the px would be keep decreasing. What I am saying, the value of px would be keep decreasing. How? Because you can see very well its denominator is going to be more and more heavier, and as its denominator is going to be more heavier, definitely its probability mass or probability of occurrence would be keep decreasing. That means the random variable would gain its value as 1, has got the probabilities 1 by 2, whereas gaining value as 2 has been reduced to 1 upon 4, gaining as 3 has been reduced to the 1 upon 8, so on and so forth, so on and so forth. Till this point, each and everything must be clear to all of us. Now here goes the next experiment. Here we are interested finding the expected value of the random variable e of x. Yes, so far many of the times in case of statistics, we have been dealing with the frequency distribution, but here in case of probability or the concept of the probability, we deal with the probability distribution. Rather the frequency distribution, we used to have probability distribution. In case of frequency distribution, we used to have the data. Towards right hand side, we used to have its frequency or repetitions. Yes, no. We used to have the class. Maybe you may have the class and its interval. And in that class or in that class interval, we used to have its repetition in terms of their frequencies. My dear friends, the concept is almost same. What I am saying? So far, you were just telling this 1 has been repeated how many times? The value used to be 1, 2, 3, 4, 5, 6, so on and so forth. But rather writing its frequencies, you have written 1 upon 2, and even 1 upon 2 has been a probability, but is still talking about the frequency or the repetition. What it indicates, out of 2 number of trial, there is a chances one time the random variable would gain its value as 1. The random value would gain its random value as 1. Similarly goes with this, and it keep goes on. Agreed? So here it goes, expected value of x, how it's been defined. Already we have derived how it is being defined. Here it becomes x of p of x, and the x would take its all possible value. At least in this problem it starts from 1 and can go till infinity. So we had to take the discrete sum of x into p of x. So let me take few of the discrete values just to know how the behavior of this discrete sum would be. So let me start with the x is equals to 1. 1 gets multiplied 1 upon 2. Simply it would be 1 upon 2. Similarly 2 gets multiplied with 1 upon 2 square. 2 I have kept as it is, it becomes 1 divided by 2 square. It goes on, and as it is going on, keep in mind the magnitude would be keep decreasing. Anyways, its discrete sum would lead the expected value of the random variable x. So may I know how we look at this value? Obviously, it has been a form of arithmetic geometric progression. How did we know about it? My dear friends, if you will keep 1 upon 2, 1 upon 2 to the power of 2, 1 upon 2 to the power of 3 aside, you will get to know the first number is 1, then 2, then 3, then 4, then 5, then 6. So obviously it is type of arithmetic progression. And for the time being, if you will be keeping 1, 2, 3, 4, 5 aside, so the first number is 1 upon 2, the second number is 1 upon 2 to the power of 2, the third number is 1 upon 2 to the power of 3. So by default, it became a geometric progression. So it has been a glue of A as well as G, arithmetic geometric progression. So I assume the student who have gone through the basic mathematics in class of 11th, and even the same sort of problem has been dealt in the last class, would be able to smash this problem out. So the AGP series with few of the calculation or the substitution has to get converted in the form of geometric progression. How it's been done? My dear friend, let me take, this has been the first equation. In first equation, what I have done, I have just divided with 2. So what is happening over here? 1 upon 2 have become 1 upon 2 to the power of 2. Why don't we bring that value over here? Yes, we can do. See, they have been sum of all of the term. So rather taking this term over here, why don't we take this term over here, so that in future the subtraction between the like term would become much easy. Similarly, this 1 upon 2 is going to multiply it with the 2 into, anyways keep 2 as it is, it becomes 1 divided by 2 to the power of 3. So here it becomes, and this process goes on, and now it's right time to subtract them out. And once we'll subtract them out, definitely the result would be a form of geometric progression. E of x gets subtracted with the e of x by 2. So the result what we get is simply going to be e of x divided by 2. Till this point, each and everything must be clear. So here it becomes half, here it becomes 2 and 1 gets subtracted, and it has been left out with only 1 upon 2 to the power of 2. Here goes 1 upon 2 to the power of 3. It goes on. My dear friends, it has been a perfect GP series, and that too, the common ratio has been lesser than word. What does that mean of it? That means the sum of the infinite term GP would converge to a certain finite value. May I know what used to be that value? That used to be a divided by 1 minus of r. What used to be a over here? The a used to be the first term, and similarly what's the r over there? It's a common ratio. Simply I am writing it ratio, but it is, yes, common ratio. It has been a common ratio. So here goes the expected value of 2 is equals to, let me add them together. The a is at what? Half divided by of 1 minus of r, that is half. Here becomes half divided by half. Obviously they get smashed out, so here the factor which will be left out is simply 1, and now the 2 is getting multiplied with 1. So the average value, expected value, or the mean value of x, which is a discrete random variable, has been precisely 2. So what's gonna be the best most answer? 2. That means on average, the value of x would be 2 if the infinite number of times the same trial has been occurring. And I would repeat once again, whenever you have been dealing with the problem related to the discrete random variable, and specifically within the discrete random variable expected value, most of the time you encounter a GP series, and you should have a clear-cut idea how to deal with those sort of problems. Yes, how to deal with those sort of problems. So till this moment of point, probably each and everything must be clear to all of us. Now it's the best time to move into the third question of the day. This problem have been taken from Engineering Services Examination Electrical year of 2019. As the thumbnail suggests, we are going to take all of the problems which are related to the GATE 2021. But this has been a recent year problem from Engineering Services Examination, specifically in electrical branch. But still this question has been the problem of the probability. So I plan to take this problem within this session itself. And yes, it has been a well-designed problem. Not just a tougher one, but yes, it has got a little bit substance to deal with. Yes. So let me take this problem into the working board. So here goes the problem. So I would suggest to each one of you, read this problem carefully and fast, and try to get the answer within 30 to 40 seconds. Tell me what would be the best most answer for this given problem. Let me see what the problem states. Here goes the solution. If the probability that an individual suffers a bad reaction from a certain infection is 0.001, what is the probability that the out of 2000 individual, more than 2 individual will suffer bad reaction? Anyways, while watching this complete frame of problem, at least the type of distribution which would be followed by this problem should be coming in your mind. My dear friends, see, may I know what is the size of the sample space? How many times the same practical values would be as I say? So obviously that is been 2000. And the number of success which we want is what? More than 2. That means it would include 3, 4, 5, 6 and would go till 2000. And if you'll talk about the success probability in each and individual trial, you'll get to know it's almost rare. The success probability is almost rare, my dear friends. Even you can smash this problem with the help of binomial distribution. But I would suggest to each one of you, as the options are being suggested, this problem has to get solved using the Poisson distribution. Anyways, let me start writing the given data. If we focus over the given data, the first data which has been given, that has been P. What is a P over there? The success probability in each and individual trial, and keep in mind this success probability used to be independent in nature while calculation, and it has been assumed so. So what is the probability? That means if one person has been tested and that person has been tested that it has been or he has been infected by a bad injection, has been my success, and its probability is being given as 0.001. Yes. What is the probability that the out of 2000 individual, that means number of trial which has been made has been 2000. Yes. And may I know what is your seeking probability? If the small x has been written as the number of success, for you the number of success is nothing but to search the people who have been affected from the bad reaction of the injection. The x is being number of success. So at very beginning, let me discuss about the range of x. May I know what would be the range of x? At worst, there is no person out of 2000 number of tests who have been affected from the bad reaction of the injection. So obviously it can start from 0 including 0, and at max it can go till 2000. So obviously you should have the clear cut idea about the NP as well as x. So if I take the reference of binomial distribution, my dear friends, how its probability mass function is being defined? It's being defined as a NCX p to the power of x q to the power of n minus of x. What it is? It's a probability for the occurrence of exactly x number of success out of n number of trial, where in each and individual trial the success probability is fixed to be p. Could you exactly understand what I am saying? So p of x, which has been the probability mass function, where the x has been taken as random variable. Anyways, keep aside the probability distribution and mass function, focus over the probability of x number of success over the binomial distribution is being defined as NCX p to the power of x 1 minus of p to the power of n minus x, where the n, p as well as q as well as x have got their own corresponding worth. But here what is happening, my dear friends? If n has been 2000, c which we are going to deal over here, it has been 3, 4, 5. So the calculations becomes much complex. So what I can do, I can apply the limiting case of the binomial distribution, and that is nothing but Poisson distribution. Keep in mind the Poisson distribution is the limiting case of the binomial distribution, and when the worth from the binomial distribution and the Poisson distribution would be almost same, it would be almost same when the number of trials are infinitely large, and similarly the success probability in each and individual trial is almost tending towards 0. Could you understand what I am saying? Anyways, even if you want, I can give its derivation, how we can reach from binomial distribution to the Poisson distribution, but I don't feel this is the right time to talk about those all calculations and all. So what I am going to do, if you have been meeting with this situation, what you can do, you can take n and p together, and as the n was trying to go towards a very larger value, p was trying to go towards very smaller value, their multiplication would be almost a finite value. For the time being, it has been written as lambda. So here the probability for exactly x number of success, which can be written in form of Poisson distribution, is gonna be e to the power of minus lambda to the power of x divided by of x factorial. Obviously the x can take its value from 0 to 2000. And what's the lambda over here? The lambda used to be the mean of the random variable. Anyways, and I am not going into the great detail of that. But yes, lambda used to be n into p, where the n is number of trial and the p is success probability in each and individual trial. So obviously the n has been 2000, has to get multiplied with 0.001. See what is happening over here, my dear friends. See, if you have shifted this dot towards one right hand side, so obviously dot would get shifted over here. Again, it would get shifted over here. Again, if that dot goes after 1, this dot have got shifted here. Agreed, no? So rather multiplying it, this is a basic knowledge which we used to study in class 8th and 9th, which can be applied easily. So obviously here it becomes 2, here it becomes 1. So the value of lambda has been precisely 2. The value of lambda has been precisely 2. And as per the problem, the value which we had to calculate is P of x greater than 2. P of x greater than 2. Even we do not have to include 2 because it has been clearly given more than 2. It is not greater than equals to of 2. If the wording would have been greater than equals to of 2, so obviously I could have taken the equal signs also. What would be the worth? My dear friends, if you add the probability of all possible values of x, definitely the result would be 1 because that would be a certain event. So the probability of x is equals to 0 plus probability of x is equals to 1 goes till probability of x is equals to 2000 would result the value as 1. But out of that you want the probability when the x is greater than 2. What does that mean of it? That means you should subtract all of the probabilities of the x which includes this range. That means you had to include x is equals to 0, you had to include x is equals to 1, and you also had to include x is equals to 2. Once you are done with this, definitely you will get the best most answer. Obviously it was a well designed sort of problem. That is why I have taken this problem over the series of gate. So what would be the best most answer? See, 1 minus of, you just had to feed x is equals to of 0. The lambda is already known to me. Even you can write over here. It's just simply e to the power of minus 2. And here it goes 2 to the power of capital X or small x, whatever is your choice, and divided by of x factorial. So while calculating the probability for having the random variable x is equals to 0, you had to feed the x is equals to 0 over here, and once we feed, so e to the power of minus 2 would remain as it is, 2 to the power of 0 would become 1, and here at denominator it would be 0 factorial, which should be simply 1. Okay, once we are done with this, we will move forward. See, once we keep x is equals to 1, what is the result we get? Here it becomes e to the power of minus 2. Here it becomes 2 to the power of 1, that's just simply 2, divided by of what it is, 1 factorial, which would again be 1. So till this moment of point, probably each and everything must be clear to all of us. And now we go with the probability for having the random variable x is equals to 2. Obviously the x has to be fed as 2 over here. So what it becomes? It becomes 2 to the power of 2 divided by 2 factorial. 2 factorial is very same as 2. So 2 to the power of 2 divided by 2 would get divided to each other. So the factor which would be left out is simply going to be 2 into e to the power of minus 2. So probably each one of us would agree on this. So end of the day, the result what we get, what it is, the probability that the x is greater than 2 has been 1 minus. They all have been in the same sign, so they would get added together. Here it becomes minus of 1, minus of 2, minus of 2. It would become minus of 5 into e to the power of minus 2. Just to match the option, e to the power of minus 2 would be brought towards downside. Its polarity of power would get reversed. The answer which we are getting precisely is going to be this. It's going to be this. So it is probability when the x is greater than 2. Probability when the x is greater than 2. So the best most answer is going to be option C, and you can expect this sort of problem over the engineering mathematics, because the guy who have a little bit idea about the gate, they would feel this problem is having lump sum symptom very same as the problem which used to appear in the gate examination. So anyways, move forward into the next question. This problem again have come from the engineering services examination. Common to all. What does it mean by the common to all? That means the same problem was faced by electrical, electronics, civil engineering, mechanical over the section 1, paper 1. The paper 2 used to be the pure technical paper, and within the electrical, even within the pure technical paper, around 6 to 7 number problem do come from the engineering mathematics. But it has been the problem for common to all. That means if you're sitting into the engineering services examination, you can experience this sort of problem within your section 1, paper 1, which used to be common to all. That is why it has been clearly written, it has been a problem of common to all. Anyways, without doing much of the delay, I would be bringing this problem into the working board. Read this problem carefully and try to sort the answer out. Try to sort this problem out. Tell me what would be the best most answer for this given problem. Tell me what would be the best most answer for this given problem. Let me read this problem thoroughly and we'll try to decode few of the important informations. A committee of 4 is to be formed. What does that mean of it? That means you will be selecting few number of boys and few number of girls, but the number of member within a formed committee has to be precisely 4. That is the first information which has been supplied along with this problem. Formed from among 4 girls. That means the number of girls which are there to select the committee has been precisely 4 and the number of boys has been precisely 5. So if we'll try to understand graphically how this problem look like. How this problem look like, my dear friends. At very beginning, it has been clearly given the number of girls which we have for the selections are simply or precisely equals to 4. That's the first information what you have. And similarly, the number of boys we have, that has been precisely 5. Precisely 5. Using the number of girls which we have, the number of boys which we have, we had to form a committee. Obviously, the committee has to come all the way from either of this bunch, either of this bunch. And you will be forming a committee now. You will be forming a committee now. Just a minute. You will be forming a committee now. Yes. Here comes a committee. Here comes a committee. But the feature of the committee has been clearly given. Feature of the committee has been clearly given. How many number of members we should have? Exactly 4 number of members we should have. The members which we should have is precisely number of 4. Yes, member. That's the first thing. Secondly, it has been clearly given. What is the probability that the committee will have the number of boys lesser than the number of girls? That means you also had to make sure the committee member or the members which has been formed within the committee, the number of girls should always be number of boys greater. The number of girls should always be greater than the number of boys. Agreed? So taking this thing in your mind, you had to calculate. You had to calculate its probability. You had to calculate its probability. My dear friends, if you really want to succeed in your agenda, how the committee can be formed? The committee can be precisely formed as probability that I have selected a committee where all of the 4 members are girls. Obviously, there would not be any inclusion of the boy anymore. Yes, it is satisfying my requirement. Or I have selected, or I have taken another consideration where within the committee we had the 3 number of girls. Obviously, the 1 member has to be boy. 1 member has to be boy. Or probability when the 2 number of girls is being selected, so obviously the remaining 2 number has to be boy. No, you cannot include this factor because it has been clearly given within the committee the sankhya of number of girls should always be greater than the number of boys. Here you can see they have been semantic in strength. You cannot take this situation. You cannot take this situation. Agreed what I'm saying? So obviously I would be keeping aside. So I have seen many other times the student do mistakes over here. So what is my basic calculation? Basic calculation is probability for the selection of 4 girl out of 4 girl and selection of 0 boy out of 5 boy, or probability for the selection of 3 girls out of 4 girls and selection of 1 boy out of 5 boy. 1 boy out of 5 boy. So obviously the same sort of problem you could have done so many times where the AND comes, where the OR comes, how the AND is being represented by the multiplication and how the OR is being represented by addition. So here the AND syntax is coming in the picture. And here OR syntax is coming in the picture. Okay, first focus over the first term, the probability when we want to select the 4 number of girls out of the 4 number of girls. How it's possible? That means we are going to select the 4 number of girls out of 4 number of girls divided by of anyways, and here it's gonna be 4C0. Yes, end of the day, how many number of how many number of chunk of the people you had, the 9 number of chunk of the people you had, and you have just selected 4. So at denominator it is coming to be NC4. NC4. Could you understand what I'm saying? So the 4 number of girls is being selected out of 4 number of girls. The 0 number of boy has been selected out of possible 5 number of boys, and similarly total 4 number of people have been selected out of 9 number of people. 9 number of people. Similarly, if we'll go ahead, the OR would be replaced with the addition sign in mathematics. Here, now you have to select the 3 number of girls, how many number of chunk of the girls we have, the 4 number of chunk of the girls we have. So here's gonna be the selection of 3 number of girls out of chunk of 4 number of girls, and the word and would get reflected in terms of multiplication, and the 1 boy has to get selected, collected, retrieved out of 5 number of boy. Anyways, at the same time, at denominator side, how many number of members has been retrieved or extracted? 4 number of member has been extracted out of total n number of people. N number of people. Could you exactly understand what I'm saying? So let me brief what this problem was exactly wanted to say. Total 9 number of members you have. Out of 9 number of members, it has been clearly given 4 are the girl and the 5 are the boys. Out of 4 number of girls and 5 number of boys, you are going to frame a committee. And it has been precisely, categorically said the number of people within the committee would be exactly 4. Exactly 4. Till this point, each and everything was okay. But now one more strict option has been given along with that problem, that whenever the committee would be formed, the number of girls should be greater than the number of boys. That means whenever you will add the number of girls and boys together, it has to be precisely 4, because it has been the mandate of that committee itself. The number of people has to be 4. So you yourself would be able to understand 4 plus 0 is also 4, 3 plus 1 is also 4. Not only that, even whenever you select the committee, you had to ensure the number of girls has to be greater than the number of boys. So at very starting, at first what I did, I have selected all of the committee members as a girl. How many they are? 4. So obviously there is no place has been left out for the boy. So boy has to be 0. Now what I did, I reduced the number of places for the girl. So from 4 I went to 3. So that means 1 vacancy has been left out for the boy. Yes. Can I go further? No, my dear friends. If you'll again reduce the number of G, which goes to 2, my dear friends, the B has to become 1, and which is against this requirement. So now this oral expression has to get converted into the mathematical expression. How the oral expression is getting converted into mathematical expression? We wanted to have the probability to get selected 4 number of girls and 0 number of boy, or I need to calculate the probability to select 3 number of girl and 1 number of boy. So whenever the AND comes, whenever the OR comes, according to that, you have to do the calculation. Tell me how much exact answer we are getting, my dear friends. So I think it's right time to calculate. So when we were talking about the short trick of NCN, the value was clearly known to me, which was nothing but 1. What does that mean of NCN? That means we had the n number of datas and you have collected all them together at once. How many times or how many ways you can do? Obviously only one time. My dear friends, it has been a certain that you are not going to select anything. Again, it would be 1 now. NC4 only we can calculate at denominator. Let me see how much it comes. So here goes NC, yes, and here comes 4. So the worth which we are getting towards the denominator of the first term is simply 126. Similarly, 4C3. May I know what used to be the value of 4C3? How many ways you can do that? So simply it's gonna be 4C, and here goes 3, which is nothing but 4. One important conclusion we have derived, what it was? The 4C3 could have been written as 4C1. Anyways, I am not going to go into that detail, but yes, it's simply going to be 4. Similarly, out of 5 number of items, you are going to select, collect or arrange only one item. How many ways you can do? You can select the first item, you can select the second item. How many ways you can do? The 5 different ways you can do. So obviously the 5C1 and C1 used to be always and always 5. So this data should be there in your mind whenever you have been dealing with the NCN. Out of n number of data, you have collected all of the data at once. How many ways you can do? Obviously, only one ways. Even if you take the data like NC1, You had the total n number of data, and at once you are selecting only one data or one item. How many ways you can do? You can select the first one, you can select the second one, you can select the third one. The n number of ways you could have selected this. You could have selected this. One more important thing. Now, if you have NC, we used to have n minus r, NCR. So rather writing NCR, if you have NC n minus of r. See what used to be the formula of NCR. At numerator, it used to be n factorial. And similarly, at denominator, we used to have r factorial. And here the r factorial is simply n minus of r factorial. N minus of r factorial. And then we used to have n minus of r factorial. The n remained as it is. The n has to get subtracted with the r, and in case of r, it has been n minus of r. So it becomes n minus of n, that becomes 0 plus of r, which is r factorial, and which is very same as NCR. You could have noticed this. You could have noticed this. Agreed, no? So what I am saying, when you have been dealing with such a large value of combination, no, you can use this formula. Rather writing it 4C3, you could have written this as 4C, 4 minus 1. 4 minus 1, and here I got the value of r, so easily the worth would have been 4C1. Easily the worth would have been 4C1, and which would have been 4 now. Which would have been 4 now. So yes, it's coming like this. It's coming like this. So end of the day, result which we are getting at numerator, it's gonna be 1 over here in this term. At numerator, here it's gonna be 20 plus of 1, that's at 21 divided by of 126. So 126 has to get divided with the 21. I would be getting the result out of this. What it is, the result what we are getting is simply gonna be 1 upon 6, sorry, 1 upon 6. It can't be 6, no? If we talk about the probability, the range has to be 0 to 1. 0 to 1. It can't go beyond this. It can't go beyond this. Till this point, probably each one of us would be agreeing the best most answer is simply gonna be D. The best most answer is simply gonna be D. So now it's right time to move into the next question, probably which would be the last question of the day. Which would be the last question of the day. Again, it has been the problem from the engineering services examination which have come recent year, because engineering services examination for the 2021 has yet to become. Tell me what would be the best most answer for this given problem. Let me take the screenshot and bring it to the working board. Bring it to the working board. Tell me what would be the best most answer for this given problem. See what the problem states. What's the problem states, my dear friends? A bag contains 4 white and 2 black balls, and another bag contains the 3 of each of the color. For the better understanding, let me take the 2 number of bags, and even I would be naming their names as bag 1 and bag 2. I have got this as a first bag. I have got this as a second bag. Yes. Let me name for the better clarity. It has been the bag 1, or you can write bag A. It has been bag B. It has been bag B. If you look inside the bag and if you talk about the distributions of the ball, it has been clearly written in bag 1 or the bag A. We had the 4 number of white ball and 2 number of black ball. Okay. So we had 4 number of white ball. 4 number of white ball. 4 number of white ball we have, and similarly, how many number of black ball we have? Just a minute. It has been clearly given the 2 number of black balls we have. So let me write their numbers. Here it 4 in count. Here it is 2 in count. 2 in count. Yes. Similarly, if you talk about the distributions of the ball in bag 2, it has been changed to. Just a minute. 3 and 3, because they are equal in count. 3 and 3. Yes. So here it goes 3 and 3. 3 and 3. See now what the problem states. A bag is selected at random and ball is drawn at random from the bag chosen. The probability of white ball drawn is. My dear friends, you can solve this problem into the 2 different methodologies. What are they? You could have used the concept of Bayes theorem, and even you could have used the concept of tree, which we have studied in the last class. And yes, one of the most design have come from that concept in GATE year of 2021, branch of electronics. So you can use either of the methodology. Either of the methodology. See, let me focus over the tree method first. Let me focus over the tree method first. First, focus over the selection of bag. First, focus over the selection of bag. Anyways, the selection of bag A and selection of bag B are being equiprobable, and hence their selection probability would be 1 by 2 and 1 by 2. So let me do one thing. Let me finish the first step first. You start the selection process of the bag. The selecting probability of bag A as well as bag B was half and half. Half and half. Yes, this was the first step. First step, which was the step of selection. Selection of what? Bag. Once you're done with this, you would go into the next step. If you select the bag A, you would search for the white ball, and similarly, if you get the bag B, you will search for the white ball. So here starts the second step. Here starts the second step. See what is happening over here. Once you select A, you could have the two possibilities. Either you land up selecting a white ball, either you land up selecting a black ball. May I know what is the probability you land up selecting a white ball? My dear friends, how many white ball you have? The 4 number of white ball you have out of total 6 number of ball. Obviously its probability would be simply equals to 4 by 6. And similarly, the probability that you have land up selecting a black ball is simply gonna be 2 divided by 6. Simply that's gonna be 2C2 divided by 6C2, and here simply gonna be 4C2 divided by 6C2. Yes. So till this point, each and everything must be clear to all of us. Similarly, if you go into the bag B, here also you have got the possibilities. Either you have just a minute. Yes. Selecting a white ball. May I know what is this possibility? How many number of white balls you have, my dear friends? 3 number of white balls you have out of 6 number of balls. So selection probability of white ball is half, and selection probability of the black ball is again half. Half and half. Half and half. Anyways, what is your favorable event that you must see over the tree? What is your favorable event? Your favorable event is to get selected a white ball. How it's possible? First, you could have selected the bag A and its probability is half, and then once the bag A got selected, you could have selected the white ball, and that's probability is nothing but the 4 by 6. Similarly, or you could have selected the bag B, and after selecting the bag B, you could have selected the white ball. So what's gonna be the best most answer? The probability for the selection of the white ball comes from the two different branches. First, half into 4 by 6, or it comes from the second branch, which is nothing but half into half. So till this moment of point, probably each and everything must be clear to all of us. And yes, the problem do come from the tree, specifically in computer science, but this year one problem have come from the tree into the gate also. So what's gonna be the result over here? So let me multiply them together towards the denominator side. What we can do, anyways, keep aside. So here it becomes 2. It becomes 1 upon 3. 1 upon 3, no? You yourself must be checking it out. The 4 gets divided with the 2. The component which will be left out is simply going to be 2. The 6 is getting divided by 2. The result which will be having towards the denominator side is nothing but 3. So the result what we get, it's simply going to be 1 upon 3 divided by 1 upon 4. 1 upon 4. So once we'll take its LCM, the LCM which we get, it's simply going to be 12. And it simply becomes 4 plus of 3. That is nothing but 7 divided by 12. So the best most answer what we get from the tree is simply going to be 7 divided by 12. 7 divided by 12. And even you could have figured it out, this problem, with the help of Bayes' theorem. You would be having the two event in background, that is E1 and E2. What they are? They are the event for the selection of bag A and bag 2. Obviously their probabilities are clearly known to me. So in future, whenever the P of E1 or P of E2 is required, I would be feeding their data as half, because their selection probabilities have been equiprobable. Their selection probabilities have been equiprobable. Till this point, probably each and everything must be clear to all of us. Now, even the white ball can come. Let's take the event for the selection of white ball has been taken as W. White ball selection. White ball selection. And now this white ball can come from either of the way. Either from the bag 1, either from the bag 2. So, if you really interested finding the probability of the selection of the white ball, which can come from the E1 as well as E2, what's the methodology you can use? You can use the P of E1 intersection of W plus of P of intersection of 2 with W. Yes, W. So till this point, each and everything must be clear to all of us. My dear friends, now we can take the help of conditional probability. What it is? We could have written this as P of E1 into P of W by E1. Similarly, P of E2 of P of W by E2. W by E2. Yes. What is the P of E1? P of E1 is half. Selecting probability of the first bag is half. Selection probability of the second bag is been half. What does it mean by the P of W by E1? Probability for the selection of the white ball when already the first bag has been selected. What it is, my dear friend, that's nothing but the 4 divided by 6. And once we'll start feeding the data, you'll get to know the P of E1 is half. P of W by E1 is nothing but the 4 divided by 6 plus, obviously they are matching. Here P of E2, that is the selection probability of the bag 2, it's half, and here goes the P of W by E2, that's nothing but the probability of getting white ball when the second bag has been selected. Again, it's been half. Tell me, did you have any difference? So I would request to each one of you, you can use the tree methodology, or either you can use the method of Bayes theorem. And I would expect from each one of you, you must be thorough in both. Because if the problem do come, which have come in this year, you require the thorough knowledge of the tree. Otherwise, you would not be able to smash that problem out using the concept of Bayes theorem. I'm not saying you will not be able to solve that problem at all using the Bayes theorem, but using the Bayes theorem, the problem was bit difficult. So, my agenda is sufficed. Totally, I wanted to take the 5 number of problems from the concept of the probability. At very beginning, I was discussing about the binomial distribution as well as expected value as well as the standard deviation of its discrete random variable. The values were n into p, comma root over of npq. Once we were done with this problem, the second problem which came in front of you was the problem from the production engineering current year, and here I was expected to get, I was calculating the expected value of small x. The formula we use many of the times, but yes, the thing which has to be focused on is 2 over AGP. It's a type of AGP. So in future, if you have this sort of problem, you should be able to smash this problem out. Once we are done with the second question, now here comes the third problem. Deliberately, I have selected this problem from the engineering services examination. Specifically came for the technical part of the electrical in year of 2019. And this problem was a problem from the concept of Poisson distribution. And they were asking, what is the probability that more than 2 individuals suffer from the bad reaction? So you could have solved this problem with the help of binomial distribution, but deliberately I took this problem into the Poisson distribution because their limiting case was almost matching, where the n was very large and p was very small, and their multiplication was leading certain finite value. Yes, we were done with this problem, and the answer which we got for this problem is simply 1 minus of 5 divided by of e square. Once we were done with this problem, we moved into the next question. This was a common question to all of the branches which has appeared in engineering services examination year of 2019. We had total 4 number of girls and 5 number of boys. We had to frame a committee which will consist total 4 number of member, but along with this condition, one more condition has been specifically given. Within that committee member, the number of girls would always be exceeding the number of boys. So how many ways it's possible? It's only been possible in 2 different ways. we had the 4 number of girls and the number of boys were absent, or you can have the number of girls as 3 and the number of boys is simply 1, and you cannot take any more varieties of the conditions which will satisfy this requirement. You will get this value, and the value has been 1 upon 6. 1 upon 6. End of the day, this has been the problem many of the times which comes into the GATE examination as well as ESE. Yes, ESE. So what is the basic concept of this problem, my dear friends? You had the total 2 number of bags. Yes, and once you'll go inside that bag, no, the collections of the colors of the balls remain same, but their quantities are different. At very beginning, the number of white balls were 4, the number of blue balls, anyways, it was black balls were 2, and similarly in second bag, the number of white balls were 3, and similarly the number of black balls were 3. And what they were telling? You select either of the bag. What is the chances, what is the probability that you would be selecting the white ball? So you have used a tree factor or tree topology. At first step, your basic intention is to select the bag itself. So selection probability of the bag A as well as bag B has been half and half. They would be equiprobable. And once you have selected once you have selected bag A, again the selection probability of the white ball and the black ball has been different as per their structure. How many number of white ball we had? 4 out of 6. So simply it's gonna be 4 upon 6, and same case goes with black. Similarly, once the bag B is being selected, if we'll talk about the selection probability of the white as well as black, how it has been? They have been equiprobable. White selection would be 3 divided by 6, black selection would be 3 divided by 6, and they would be leading as a 1 upon 2, 1 upon 2. End of the day, you had to get a white ball. How it's possible? All the way you had to start from a starting point. After taking the probability of half, you got selected with bag A, and now from the bag A you had to take a white ball out, and that's possible only 4 times out of 6 times, and that means the probability is simply 4 upon 6. So once we add them together, the value which we got is simply going to be 7 divided by 12. 7 divided by 12. Yes. Anyways, ending this today's session, I would like to take the feedback and the concurrence. If any sort of doubt you guys had till this 5th question, you can ask over the live chat. So probably I would be waiting for your responses for the next 3 to 4 minutes, and then we'll bind today's session. Then we'll bind up today's session. Tell me, is you guys are having any sort of doubt? If you guys are having any sort of doubt, if you have, you can put it over the live chat. So at least I'll have the fair idea. I'll have the fair idea. So probably no doubt as such. Okay then, precisely at 9 PM we would be meeting tomorrow, obviously with the same agenda, where we are taking the reference of previous year questions which have come from the engineering mathematics, and with the help of those questions we are preparing for GATE 2022. All the solutions already done in board. No, I could not understand. Pravakar sir, what was your exact intention over the frame of wording? I could not exactly understood. So I think you should be elaborating it once again. You should be elaborating it once again. All the solution already done in board. I could not understand. Anyways, we will be meeting precisely tomorrow at 9 PM, and I would suggest to each one of you, the people who have been live, they must subscribe our channel, so that in future whenever we are live or we are sharing any sort of video, those valuable videos would get reached to you, easiest form of monitoring. Agreed? So we'll meet tomorrow precisely at 9 PM till 9 to 10. Okay then, bye bye, take care, good night.